In this lecture, we are going to discuss working formula of number system. The first formula of the number system is if modulus of x is less than a, then x less than a, x less than a, and x is greater than minus a. If modulus of x is less than a, then we can write x less than a and x greater than minus a, and vice versa. That means if x is less than a and x is greater than minus a, then again we can write modulus of x less than a. Second formula, the modulus of complex number x plus iy, or we can say the absolute value of the complex number x plus iy is equal to root under x square plus y square. Number 3, the conjugate of complex number x plus iy. The conjugate of the complex number x plus iy is x minus iy, and vice versa. That means conjugate of x minus iy, we can write x plus iy. The fourth formula of number system is I is equal to root of minus 1. I is the imaginary unit, or we can say a complex number having the real part 0 and imaginary part 1. So the value of I is equal to root of minus 1, where I is equal to 0, 1. I square, that means the square of imaginary unit is equal to minus 1. So when we take the square, when we take a square on both sides, then I square will be equal to, root will cancel, we get minus 1. So from number 5 is I square is equal to minus 1. Number 6, the square of the modulus of any number is equal to the square of the given real number, because both give the same positive value. Number 7, modulus of x plus iy is less than or equal to modulus of x plus modulus of y. This is also known as triangle inequality of real numbers. Number 8, a comma b. If any complex number is given a comma b, then we can write the given complex number in terms of imaginary unit I. That means a comma b we can write as a plus ib. Number 9, a comma 0. The complex number a comma 0 we can write equals to a. That means if the imaginary part of any complex number is 0, then the complex number we can represent by its real part. So a comma 0 we can write as a, because imaginary part is 0. So we can represent it by real part, which is equal to a. A comma 0 is equal to a. For number 10, addition of two complex numbers. So when we have to add any two given complex number, then the sum of two complex numbers we get by adding the corresponding real parts by adding the corresponding imaginary parts. That means a comma b plus c comma d we can write as a plus c comma b plus d. And the last formula, number 11, is a comma b into c comma d. That means to find the product of any two complex number, a comma b into c comma d, we can apply the formula ac minus bd comma ad plus bc. That means a comma b into c comma d we can write as ac minus bd. That means we have to take the difference of the product of real parts and the imaginary parts. Then we get real part comma ad plus bc. That means real part multiply with imaginary part and imaginary part multiply with the real part. Then we get ad plus bc, which is the imaginary part of the two complex number when they are multiplied. So a comma b into c comma d we can write as ac minus bd comma ad plus bc. Thank you. Fine. In this lecture we are going to discuss solved examples of number system. Example 1, if minus 10 is less than 5x plus 10 less than 5, then we have to prove that minus 4 is less than x less than minus 1. Solution, so we are given minus 10 less than 5x plus 10 less than 5. So two inequalities are given in the combined form. Now in order to solve the given inequality, we have to find the value of x. We have to find the value of x. That means to find the value of x, we'll eliminate 5 and again we'll eliminate plus 10. So let's eliminate, that means remove 10 from the given inequality. So let's subtract minus 10, subtract minus 10, subtract minus 10. So we subtract 10 from each part of the given inequality. So minus 10 will be minus 20, plus 10 minus 10 will cancel, we get 5x, 5 minus 10 we get minus 5. Now to eliminate, that means to remove 5, dividing by 5 to each part. So if we divide by 5, each part of the given inequality, then we get 5 4 is 20 minus 4, 5 5 cancel, we get x, 5 5 cancel, we get minus 1. So we get minus 4 less than x less than minus 1. Hence we get the required solution. Hence it is proved. The second example of number system. Rewrite without absolute value sign. We have to write without absolute value sign. Modulus of x minus 3 is less than 2. Solution. Modulus of x minus 3 less than 2 is given, and we have to write this statement without absolute value sign. We know if modulus of x is less than a, so we are going to use the formula of modulus of a real number. If modulus of x is less than a, x minus 3 comparing with x and 2 comparing with a. So if x is less than a, if modulus of x is less than a, then x we can write less than a and x greater than minus a. So this is the formula of modulus, or we can say absolute value of a complex number. So modulus of x, it is given x minus 3 less than 2. Modulus of x minus 3 less than 2 is given to us. So now by using the formula, x let us replace by x minus 3 and a minus a replacing by minus 2 and plus a replacing by plus 2. That means if modulus of x minus 3 is given less than 2, then x minus 3 we can write less than 2 and x minus 3 we can write greater than minus 2. Let's solve it now. Now we have to find the value of x by solving this inequality. So to solve this inequality, we have to eliminate minus 3 from the middle part. So to cancel this minus 3, we have to add plus 3, plus 3, plus 3 on each part. So minus 2 plus 3, x minus 3 plus 3, 2 plus 3. So plus 3 minus 3 will cancel, we get x, 2 plus 3 is 5, and 3 minus 2 is 1. So this is the required solution. That means if we rewrite the given statement modulus of x minus 3 less than 2 without absolute value sign, then we get modulus of x minus 3 less than 2, we get 1 less than x less than 5. Solved examples of number system. Example 3. Rewrite using absolute value sign minus 6 less than x less than 2. So this is the given inequality, and we have to write it by using absolute value sign. Solution. Minus 6 less than x less than 2 is given, so we have to change this into absolute value sign. To change this into absolute value sign, we have to make the numbers from left side and right side, the numbers of left side and right side both equal. Then only we can convert this into absolute value sign. Now to make the numbers of left side and right side both equal, we'll take the sum. So let's look at the rough. We'll do some calculation. First, to make the numbers of left side and right side equal, we take the sum. Minus 6 plus 2, we get minus 4. This is the first step. Then the sum we divide by 2. Minus 4 divided by 2 is minus 2. Then we change the sign. Minus 2, if we change the sign, then we get plus 2. So this is the rule of balancing. That means making the number of left side and right side equal. So we follow this 3 steps. Take the sum, divide by 2, and change the sign. So we have got plus 2. So adding plus 2, adding 2 on each part. So minus 6 plus 2, we get minus 4, x plus 2 as it is, 2 plus 2, 4. Now the numbers of left side and right side both are equal. We know if modulus of x is less than a, then x we can write less than a, x we can write greater than minus a. So already we have got the numbers of left side and right side both are equal. So comparing with the formula, minus a less than x less than a, minus a less than x less than s. If minus a is less than x less than a, then we can write modulus of x less than a. That means if the numbers on both sides of any given inequality are equal, then we can write the given inequality in terms of absolute value. So this x plus 2 is less than 4, x plus 2 is greater than minus 4. So we can write modulus of x plus 2 less than 4. So this is by using the formula. If modulus of x is less than a, then minus a. X is less than a and x is greater than minus a, and vice versa. So we have got the proof. We have got the solution. That means if minus 6 is less than x less than 2, then if we change this into modulus sign, then we'll get modulus of x plus 2 less than 4. Example 4, if x plus iy is equal to root of 1 plus iy 1 minus I, so that x square plus y square is equal to 1. Solution, we are given x plus iy is equal to root of 1 plus I by 1 minus I. So this is given to us, and by solving this we have to prove that x square plus y square is equal to 1. X plus iy is given root of 1 plus I by 1 minus I. So first step, we are going to multiply by the conjugate of denominator. 1 minus I is the denominator. The conjugate of 1 minus I is 1 plus I. So dividing and multiplying by the conjugate of 1 minus I. 1 plus I into 1 plus I will get 1 plus I whole square. A plus b and a minus b. That means we'll get a square minus b square. Square and root will cancel. We get 1 plus I. 1 square means 1. I square value is minus 1. Minus minus plus 1. We get 1 plus I by root 2. Now we'll take modulus on both sides. Modulus of x plus iy is equal to modulus of 1 plus I by root 2. We get 1 by root 2 because modulus of root is root 2. Then modulus of 1 plus I. Now according to the formula of modulus of any complex number, modulus of x plus iy is root x square plus y square. Modulus of 1 plus I, x square plus y square. That means 1 square plus 1 square. The coefficient of I is 1. 1 square plus 1 square, we get 2 root 2, 1 plus 1 2. Root to root will cancel, then we get 1. That means the value of x square plus y square is equal to 1, because when we do squaring on both sides, then x square plus y square value will get 1. Thank you.